In September 2025, the global internet faced a severe physical stress test. Deep under the Red Sea, a geopolitical flashpoint physically severed multiple critical subsea cables, SeaMeWe 4, IMWE, and Falcon among them. This wasn't just a software glitch or a minor routing error. It was the violent intersection of terrestrial conflict and underwater infrastructure. For legacy telecoms, the impact was immediate and catastrophic. Millions of enterprise and individual users across the Middle East, South Asia, and Africa experienced severe latency and connectivity issues. The traditional network, like a congested toll road, hit a physical blockade. Data packets were dropped, traffic jammed, regional economies temporarily slowed. Yet, the world's largest tech conglomerates, the hyperscalers, barely flinched. To understand why, we need to look at the physical reality of the cloud. 95% of global data travels not through satellites, but through fragile fiber optic cables resting on the ocean floor. When the Red Sea cables were cut, traditional telecom operators scrambled, completely dependent on shared choke points and outdated maritime repair protocols. Hyperscalers, on the other hand, had built a completely different system. Their networks rerouted signals instantly and autonomously. Algorithms detected severed glass threads and pulsed massive volumes of data through alternative pathways, like new lines through the Java Sea or down Africa's west coast. The modern internet survived the Red Sea crisis because it no longer relies on legacy toll roads. It's now governed by corporate algorithmic resilience. Big tech no longer rents bandwidth. They own the ocean floor. To understand this structural decoupling, we must analyze telecom and cloud economics. Historically, subsea cable networks were built and managed by state-backed consortiums. Hyperscalers were just high-volume tenants, renting bandwidth as an OpEx expense, carefully managed each quarter. But the growth of cloud computing and enterprise AI broke this model. The massive data volumes required for large language models and global workloads made leasing bandwidth inefficient and risky. The telecom industry now faces severe capital pressure. Wholesale bandwidth prices are dropping about 10% annually, while hardware costs, energy consumption, and capital intensity surge. Delivery lead times for hardware have jumped from 8 to 26 weeks in many cases. Private equity is pouring money into terrestrial fiber and localized AI data centers. Transit pricing is hyper-competitive. For legacy operators, building true redundancy is expensive. They'd have to double their capital exposure to create fully independent backup routes. Smaller operators can't absorb this margin compression, so they delay upgrades, reduce geographic diversification, and rely on shared paths. Hyperscalers saw this fragility and shifted to owning the physical internet. They moved from bandwidth renters to sovereign infrastructure owners, turning CapEx into a strategic advantage. The ocean floor is a hostile environment. A terrestrial fiber cut can often be repaired in 8 to 12 hours. A severed subsea cable? Minimum 2 weeks, sometimes over 250 days. Natural disasters, seismic activity, anchor drags, and sabotage all threaten these cables. During the September 2025 Red Sea crisis, insurance premiums for repair ships jumped 50% due to the conflict zone risk. There's also a critical shortage of marine repair vessels. Globally, only 62 specialize in subsea cable maintenance, 19 exclusively. Commissioning new vessels takes 3 to 5 years, and demand is skyrocketing. Predictive models suggest 141 subsea cable repairs will be needed in the Southwest Pacific by 2040, nearly half of all global anticipated faults. Without fleet expansion, the global economy faces a severe repair bottleneck. Sovereign states are beginning to respond. Japan, for example, subsidizes new ships for its domestic neck. Hyperscalers are using their balance sheets to redesign global data flows. In early 2026, Google launched the America-India Connect initiative, 3 new proprietary subsea cables. These new pathways bypass the congested Red Sea and the monitored South China Sea. One system links India's east coast through South Africa to the US east coast. Another connects via Singapore to Southeast Asia. A third bridges Western Australia to the US Pacific, integrating with Link and Hona Moana. Meta also deployed new cables from Singapore to the American West Coast via the Java Sea, avoiding South China Sea uncertainty. These networks aren't passive fiberglass conduits. They're AI-managed, intelligent systems. The EU invested €347 million into strategic subsea projects, including €20 million for smart cable equipment, sensors integrated into infrastructure for real-time monitoring. AI algorithms preemptively detect unauthorized seabed activity or natural disturbances before a cut occurs. Workloads are dynamically shifted to maintain latency and capacity. The aggressive, capital-intensive deployment of proprietary subsea cables has reshaped global geopolitics. International data flow is decoupling from sovereign control. Historically, nation-states wielded immense power over information by regulating physical telecom infrastructure. But modern hyperscaler networks operate on a different plane. While governments push for data sovereignty, they are losing control of the infrastructure that moves the data. Data sovereignty without infrastructure sovereignty is partial and illusory. Core networking hardware, optical systems, and transoceanic corridors are now consolidated under a few multinational US-based tech giants. Sovereign responses cannot match corporate velocity or scale. By moving from renters to sovereign infrastructure owners, these companies insulated themselves from legacy telecom margin pressures and geographic friction zones. Their subsea nervous system is arguably the most efficient and resilient communication grid in human history, governed by algorithms rather than slow political consensus. The international community now faces a critical question. If multinational corporations govern and stabilize the global internet, how can sovereign states enforce regulation without disrupting this highly efficient, unified network?